Summer, 1931. Black Canyon, Nevada. The temperature climbs past 120 degrees Fahrenheit inside the canyon walls. A worker named J.G. Tierney operates a Marion steam shovel, one of 40 such machines tearing through solid rock to carve diversion tunnels 56 feet in diameter. The shovel weighs 95 tons. Its bucket bites into granite with hydraulic force equivalent to crushing a car. Tierney has been on shift for 11 hours. The cockpit of the shovel offers no shade, no ventilation, no relief. His hands blister on the metal controls. Sweat soaks through his shirt, but it doesn't cool him. The air inside the tunnel is too hot, too thick with steam and rock dust. At 3:47 p.m., he collapses against the controls. Heat exhaustion. Then he's the first of 42 men who will die of heat stroke that summer alone, not from falling concrete or drowning in the Colorado River, but from operating the machines designed to tame it. The official death toll for Hoover Dam construction stands at 96 workers. The dam itself, 726 feet tall, 660 feet thick at its base, containing enough concrete to pave a highway from New York to San Francisco, gets credit as one of humanity's most dangerous construction projects. But here's what the official record doesn't capture. The machines that made the dam possible killed more men than the dam ever could. This is their story. What happens when you give 5,000 workers equipment designed for speed, not safety, and tell them to finish 2 years ahead of an already impossible schedule? But Frank Crow earned his nickname Hurry Up Crow before he ever arrived at Black Canyon. The 49-year-old superintendent had built dams across the American West, but nothing approached the scale of what the Bureau of Reclamation demanded here. The Colorado River carried 100 million tons of silt annually through a canyon, with walls rising 800 feet on either side. Summer temperatures inside the canyon reached 130 degrees. Winter floods could surge to 200,000 cubic feet per second. The river had to be stopped, diverted, and controlled before the first bucket of concrete could be poured. Six Companies, Inc., a joint venture formed specifically for this project, won the bid at $48.9 million, roughly $700 million in today's currency. The contract included a completion deadline so aggressive it seemed designed to fail. 7 years to finish what engineers estimated would take 9. Frank Crow accepted the challenge with a simple philosophy: run everything faster, push every machine harder, and never stop moving. He would need machinery that didn't exist yet, and he would need men willing to operate it. The Bureau of Reclamation's specifications for the diversion tunnels read like an engineering fever dream. 4 tunnels, each 56 feet in diameter, wide enough to drive 3 semi-tracks side by side, each stretching 4,000 feet through solid volcanic rock. Combined, they would divert the entire flow of the Colorado River around the construction site, allowing workers to build the dam in a dry canyon. No tunnels of this diameter had ever been drilled through solid rock on this timeline. Standard mining equipment couldn't approach the speed Crow needed, so he designed his own. Marion Power Shovel Company delivered the solution. Custom steam shovels weighing up to 95 tons each, mounted on rail cars, capable of excavating 8 cubic yards of rock per bite. 40 of these machines would work simultaneously, advancing through the tunnels 24 hours a day in 3 shifts. Each shovel consumed 2 tons of coal daily. The boilers generating steam pressure reached temperatures of 350 degrees Fahrenheit. Operators sat in open cabs with no protection from heat, dust, or flying rock fragments. The tunnels themselves became ovens. Air temperature inside exceeded 140 degrees during summer months. Men working near the shovels described the air as too thick to breathe properly. Understanding how a Marion steam shovel worked requires understanding what made it lethal. The machine operated on a simple principle: convert water to steam, use steam pressure to drive hydraulic pistons, and transfer that force to a massive dipper arm and bucket. At the heart of each shovel sat a riveted steel boiler holding water under pressure between 150 and 200 pounds per square inch. When that water converted to steam, it expanded with explosive force. A single cubic foot of water becomes 1,600 cubic feet of steam. That expansion drives pistons connected to the bucket arm through a system of cables, pulleys, and gears. The operator controlled 4 primary functions: boom swing, crowd, hoist, and travel. Swing rotated the entire upper structure. The crowd pushed the bucket into the rock face. Hoist lifted the loaded bucket. Travel moved the machine forward on its rails. Each function required judgment calls made in fractions of a second. Push too hard on the crowd lever and the bucket teeth shatter against granite. Pull the hoist too fast and the cables snap. Swing the boom too quickly and the entire machine could tip sideways off its rails. The learning curve was measured in broken equipment and broken men. Steam pressure had to remain constant. Too low and the machine lost power. Too high and pressure relief valves opened with a scream that could deafen operators. The safety valves were supposed to prevent boiler explosions. But in Black Canyon, safety valves were often wired shut or weighted down. Why? Because releasing steam meant stopping work. Stopping work meant falling behind schedule. Falling behind schedule meant Frank Crowe asking questions nobody wanted to answer. The excavation process unfolded in brutal sequence. First, drilling teams mounted on trucks called jumbos would advance to the tunnel face. A jumbo rig was a flatbed truck carrying a steel framework holding up to 30 pneumatic drills positioned at precise angles. The truck would back up to the rock face. Drilling crews would climb the framework and begin drilling a pattern of holes 30 feet deep into the granite. The noise was continuous and overwhelming. Each pneumatic drill operated at 2,000 strikes per minute. Multiply that by 30 drills working simultaneously. Workers stuffed cotton in their ears, but the vibration entered through bone conduction. Men working 8-hour shifts on the jumbos reported permanent hearing loss within weeks. Once the hole pattern was complete, demolition crews loaded each hole with dynamite. A single blast consumed 5 tons of explosives. The tunnel face would be cleared. The blast would detonate. Rock fragments weighing up to 300 pounds would fill the tunnel. Then the Marion shovels would advance, their operators climbing into cabs still hot from steam leaks and bearing grease. The shovels would work for the next 6 hours, loading broken granite into rail cars that hauled it out of the tunnel on narrow-gauge tracks. The sequence would repeat, 3 times per day, 7 days per week, for 2 solid years. The operators breathed dust so thick it coated their lungs. Silicosis, a progressive lung disease caused by inhaling crystalline silica dust, would kill more tunnel workers in the decade following construction than any single accident during it. But silicosis deaths don't appear in the official toll. Those men died slowly in hospitals scattered across Nevada and California. Their deaths never connected back to Black Canyon. If you worked a tunnel for 6 months and died of lung failure 3 years later, your death was your problem, not 6 Companies Inc.'s problem. The cableways represented the most visible and most terrifying machines Frank Crowe deployed. 8 steel cables stretched across Black Canyon, suspended between towers anchored into the canyon rims. Each cable hung 800 feet above the canyon floor. Each could carry a bucket holding 8 cubic yards of wet concrete, roughly 20 tons when full. The cables moved the buckets at speeds up to 80 feet per minute, swinging them out over the dam site and lowering them to precise coordinates where concrete crews waited. Operating a cableway required 3 men, a high operator who controlled the main cable, a low operator who managed the bucket release, and a signalman who coordinated between them using hand signals. Radio communication didn't exist. In wind, rain, or blinding sun, the signalman stood exposed on scaffolding, waving flags to direct buckets swinging on cables thinner than a man's wrist. If a cable snapped, and cables did snap, the bucket would fall 800 feet, accelerating to terminal velocity before impacting whatever sat below. A 20-ton concrete bucket striking the canyon floor created a crater 6 feet deep. If workers were underneath, no amount of speed could save them. The cables themselves were engineering marvels and death traps in equal measure. Each main cable measured 2 inches in diameter, woven from hundreds of individual steel strands. Cable strength was rated at 160 tons. But strength ratings assume perfect conditions. No rust, no metal fatigue, no microscopic cracks spreading through wire strands under constant stress. Black Canyon offered none of these conditions. Summer heat expanded the metal. Winter cold made it brittle. Concrete dust corroded the surface. The cables were inspected daily, but inspection meant a man climbing the cable support towers and examining the steel with his eyes. No x-rays, no stress testing, no margin for error. Could you imagine working beneath one of these cables, knowing that 20 tons of concrete hung 800 feet above your head, held by a cable that might fail without warning? On August 17, 1932, a cableway cable snapped during a concrete pour. The cable had been inspected that morning and passed. By 2 p.m., metal fatigue had progressed far enough that the cable parted. The bucket fell in silence. Impact killed 3 men instantly. A 4th man died 6 hours later from internal injuries. The investigation was brief. 6 Companies Incorporated replaced the cable and resumed operations within 48 hours. The dead men's families received $5,000 each. No criminal charges were filed. The men who operated these machines came from everywhere and nowhere. 6 Companies Incorporated advertised nationally but hired locally when possible. Preference went to experienced equipment operators, but experience was often measured in weeks, not years. Pay started at $4 per day for common labor and reached $5.60 for skilled machine operators. Decent money in 1931, when the Depression had 25% of the American workforce unemployed. Men arrived in Black Canyon from farms in Oklahoma, failed businesses in California, shuttered factories in Pennsylvania. They arrived desperate and stayed desperate. Frank Crowe ran a company town called Boulder City, purpose-built to houseworkers. But Boulder City sat 7 miles from the construction site, and transportation was limited. Many workers lived in a sprawl of tents and shacks called Ragtown, erected on the canyon rim without sanitation, running water, or electricity. Summer nights offered no relief from daytime heat. A winter brought freezing temperatures. Men slept 4 to a tent and woke at 4 a.m. to begin the trek down into the canyon. Training was informal and brief. New operators would shadow experienced men for a shift or two, learning by watching. Then they'd take the controls themselves. Marion shovels, jumbo rigs, and cableway stations all required spatial awareness, mechanical intuition, and steady nerves. What they didn't require was any background in engineering or physics. Most operators had never seen a steam boiler before arriving at Black Canyon. They learned pressure management through trial and catastrophic error. The men who survived long enough became experts. The men who didn't became statistics. The work was 12-hour shifts, 6 days per week minimum. Frank Crowe walked the tunnels personally, checking progress against timelines. And if a crew fell behind, he'd appear, stand silently, and watch until production increased. The message was clear: speed was survival. The arithmetic was simple and cruel. Shut down your machine to report a steam leak, and you'd be replaced by tomorrow. 6 companies incorporated maintained an industrial reserve, a pool of unemployed men waiting for current workers to quit, collapse, or die. For every man operating a Marion shovel, 3 men waited to take his place. This wasn't a threat. This was policy. On November 3, 1931, operator Henry Wallace failed to notice a failing pressure relief valve. The valve stuck closed. Pressure climbed past 220 pounds per square inch. At 241 pounds per square inch, the boiler shell ruptured. Superheated steam at 350 degrees Fahrenheit filled the operator's cab in under 2 seconds. Wallace died at the scene. His body showed third-degree burns over 90% of its surface. Steam doesn't just burn, it cooks living tissue from the inside out. The heat made everything worse. Inside the tunnels during summer, temperatures reached 140 degrees Fahrenheit with humidity approaching 100%. Men drank water continuously but couldn't sweat fast enough to cool their core temperatures. Heat exhaustion symptoms include confusion, dizziness, and impaired judgment. Exactly the states you cannot afford when operating a 95-ton machine with superheated steam at 200 psi. By the end of that summer, 42 men had died of heat stroke. The mathematics of death tell a story 6 companies incorporated preferred not to acknowledge. Between 1931 and 1935, approximately 21,000 men worked on the dam. And using the official count of 96 deaths over 1,540 days yields 1 workplace fatality every 16 days. Modern analysis suggests the true toll exceeded 140 workers, 1 man dead every 11 days, not from building a 726-foot dam, but from the machines, the heat, and the schedule that prioritized speed over survival. This kept happening because the economic logic was irresistible. The construction contract included bonus payments for early completion, $3,000 per day for every day ahead of the 7-year schedule. By pushing equipment and men to their limits, Frank Crowe could capture bonuses totaling over $2 million, at roughly $40 million in today's currency. Against that incentive, the cost of occasional worker deaths seemed manageable. 6 companies incorporated maintained insurance policies that paid out between $5,000 and $10,000 per fatality. Depending on the worker's classification. Even with 140 deaths at $10,000 each, total payouts reached $1.4 million, less than the bonus earned by finishing 1 year ahead of schedule. Federal workplace safety regulations in 1931 were minimal and rarely enforced. The Walsh-Healy Public Contracts Act, which would establish basic safety standards for federal contractors, wouldn't be enacted until 1936, after Hoover Dam was complete. OSHA, the Occupational Safety and Health Administration, wouldn't exist until 1970. Workers had virtually no legal recourse for workplace injuries. Nevada's workmen's compensation laws capped payouts and explicitly exempted employers from negligence claims if the worker accepted compensation. The system was designed to protect companies, not workers. Newspaper coverage of construction deaths was sparse and localized. The Las Vegas Evening Review-Journal reported major incidents, but often buried them in back pages. National media celebrated the dam as a triumph of American engineering and New Deal optimism. The human cost was considered an unfortunate but acceptable price of progress. Editorials praised Frank Crowe's management efficiency and 6 Companies Inc.'s ability to meet impossible deadlines. Nobody mentioned the bodies. Insurance company records paint a different picture. Hartford Steam Boiler Inspection and Insurance Company, which insured several of the Marion shovels, documented unsafe operating conditions including inadequate ventilation, excessive ambient temperatures, and widespread safety valve tampering in internal reports from 1932. These findings were shared with 6 companies incorporated. Ventilation improvements were recommended, costs were estimated at $75,000, the improvements were not implemented, production continued, internal memos obtained decades later through FOIA requests revealed discussions about acceptable casualty rates and cost-benefit analysis of safety improvements. A 1933 memo from project accountants notes that worker replacement costs including recruitment, transportation, and death benefits average $8,500 per fatality, while slowdowns from implementing enhanced safety protocols would cost an estimated $12,000 per day in lost bonus payments. The math was explicit. Dead workers were cheaper than safe workers. Change came slowly. What ultimately shifted the equation was insurance companies. After analyzing claims data from Hoover Dam, various insurers began refusing coverage or charging prohibitive premiums for contractors with poor safety records. Self-interest achieved what regulation could not. By the late 1930s, diesel engines began replacing steam power. Diesel eliminated the explosion risk from pressurized boilers. Enclosed, ventilated operator cabs became standard. None of these advances were motivated by worker welfare. They emerged because they increased machine reliability and reduced downtime. The last Marion steam shovel at Hoover Dam shut down in October 1933, when tunnel excavation completed. The machines were sold, scrapped, or reassigned to other projects. None survive in museums. The cableways operated until the final concrete pour in May 1935, then were dismantled and sold for their steel. The jumbo rigs were repurposed for mining operations across Nevada and Arizona. The physical evidence of the machinery that killed 140 men has vanished. What remains are the tunnels themselves, 4 perfectly round passages 56 feet in diameter, stretching 4,000 feet through solid rock, now carrying the diverted Colorado River around the operational dam. You can visit those tunnels today. Tours run during low water seasons, when river flow allows safe access. The walls still bear drill marks from the jumbo rigs. The rock still shows scorch marks from dynamite blasts, but nothing on those walls commemorates the men who died excavating them. The Bureau of Reclamation's official visitor center displays photographs of the Marion shovels and cableway systems, accompanied by text celebrating unprecedented engineering achievements. The heat deaths are not mentioned, the boiler explosions are not mentioned, the pattern of systematic risk acceptance is not mentioned. The regulatory framework born from this era shapes workplace safety today. OSHA's regulations on heat stress, machinery operation, and construction site safety trace directly back to investigations of projects like Hoover Dam. The American Society of Mechanical Engineers boiler codes, still in use today, were refined through analysis of industrial boiler failures in the 1930s. Insurance industry safety standards evolved from actuarial data gathered at projects where workers died at statistically predictable rates. We built our modern safety culture on a foundation of casualties. The lesson is uncomfortable but clear. Progress has a price, and someone always pays it. The question is whether that price is deliberate policy or tragic accident, whether it's acknowledged or hidden, whether it leads to change or more of the same. At Hoover Dam, the machines were more dangerous than the dam itself because we chose to make them that way. The danger was never necessary, it was expedient. Hoover Dam stands as a monument to American ambition. The structure has generated 4 billion kilowatt hours annually since 1936. It provides water to 25 million people. But these achievements were purchased with lives. In 1995, the Bureau of Reclamation installed a memorial plaque listing 96 workers who died. The list is incomplete. It omits men like James Morton, who died from blast injuries 2 weeks after an explosion. It omits Michael Sullivan, who died 3 years later from silicosis. It omits the estimated 44 additional workers whose deaths were never officially connected. The machines at Hoover Dam, the Marion shovels, the jumbo rigs, the cableways, were not inherently deadly. They became deadly through choices made by people who prioritized speed and profit over human life. That same pattern continues in industries where regulation is weak and enforcement weaker. We end where we began, in that moment when J.G. Tierney's body temperature climbed past the point of no return, operating a machine in conditions that guaranteed his eventual collapse. But now, we understand every decision that led there. The question is whether we've learned enough to prevent it from happening again. The dam will stand for centuries. The machines are gone. What endures is the principle written in their operation. When economics confronts ethics, economics usually wins unless law intervenes. At Hoover Dam, 140 men paid with their lives, not for the dam itself, but for our impatience in building it. The next time you turn on a light powered by Hoover Dam's generators, remember the machine operators who died to flip that switch. Remember J.G. Tierney, first victim of the heat. Remember Patrick Tierney, his son, last recorded casualty. Their labor built the dam, their deaths built the regulatory framework that protects modern workers. If stories like this move you, if you believe these forgotten workers deserve to be remembered, consider subscribing to help preserve the history of those who built our world.